k-anonymisation and synthetic data techniques. So please.
Yes, so before I start, maybe two important things. First of all, the slides are quite full, but I hope to share them with you afterwards so that they contain all information. So maybe I will not discuss everything on the slides, but I will make sure the slides are provided. Second of all, not unimportant, Birgit mentioned to make sure that we have an outfit. Unfortunately, I think I will be the only presenter doing so, but I made the promise, so let me start off by changing. All right, and then we can start. With the energy cost and machine learning accuracy impact of k-anonymization and synthetic data techniques. So, well, this is me, a student of the Master Artificial Intelligence from the University of Amsterdam, and this is Anna. She was my supervisor for my bachelor thesis, and that's what resulted in this paper. Okay, so why should we bother in the first place? Well, we have the EU Green Deal, which makes a policy to reduce greenhouse gas emissions by 55% by 2030. And on top of that, we also have the GDPR, which, well, considers the protection of personal data. And what's interesting to this GDPR is that anonymized data is not is an exception to the GDPR. So what we don't know yet is what is the energy cost of privacy enhancing techniques, such as anonymization methods, and what is the impact on the accuracy of machine learning, and what does it do with the energy consumption? So what we explored earlier was privacy enhancing techniques as k-anonymity, and we will also include synthetic data in this research. So first of all, k-anonymization was first introduced a long time ago by Samatari, and one way to obtain it is by microaggregation. And what we do is we have the data on the left. Wish I could point at it, but then I don't have a microphone. We have the data on the left, so the 6, the 8, and the 5. And when we say that we want to obtain k-anonymity, we average these data points, and then we have the output to the right. And now, as you can see, we have 3 5s, for example, in the right column. So on the left, we have some unique values, which could be traced back to a person, for example. But on the right, for each value, we have 2 other values that are exactly the same. So we cannot distinguish those from each other anymore. And that would be microaggregation. We also have generalization and suppression, which was used in our research. And what that does is that it either suppresses information that can link back to a unique person, for example, addresses, which are unique, but also you could think of zip codes. And that's an example to the right. There we see unique values on the bottom. And when we have a k-anonymity of 1, that means, for example, we have 10, 9, well, star. And then those 2 values underneath cannot be distinguished from each other. So if we increase even more to a k of 3, then all those 4 values will be indistinguishable from each other. Okay, then we want to measure the energy consumption. We could do that with a hardware solution, as presented in the first presentation. But as you also might have noticed, it was quite expensive, and it requires quite some work to do that. So we used a software approach, namely RAPL, which is the running average power limit, which measures the energy consumption in Intel chips. And we use PyRAPL to implement this, which is a Python package that uses these RAPL counters to measure the energy consumption, which is actually developed together with the University of Lille and India. So that's where we are right now. And we see that it's not that very accurate, but it correlates up to 99 with, well, the hardware setup. So it is quite accurate. Okay, then related work. Focused on k-anonymization techniques, and last year was actually presented here also at ICT4S that the k value has a statistically significant impact on the energy consumption of the chosen anonymization algorithms. And generalization and suppression work better than microaggregation, so that's what we use for this research as well. And we found that models trained on generalization and suppression perform better. So that got us thinking, and we saw synthetic data was increasingly in the news, and that's we thought, well, why not compare it to synthetic data? So why would we use synthetic data? Well, because it enhances the privacy of data, And the promise is that synthetic data is similar to the original data set, so it would have the same statistical properties. And as far as we know, there was no research done yet on the energy consumption, so that was really interesting. Okay, so this is our experimental setup. We have two data sets. We have a baseline which we do not anonymize. We have a baseline which we use generalization and suppression to obtain k-anonymity. And then we have another factor which is synthetic data. And then we use 3 different machine learning techniques to see the impact on the accuracy and the energy consumption. All right, what we used for synthetic data is data synthesizer because literature showed that that was most accurate. And how it works, then again, I will provide the slides, so I'll go through it really quick, is at first it will analyze the data, then it will try to generate new data, and then it will test if it actually represents the original data. All right, so then we use those 2 data sets and the following machine learning techniques: logistic regression, k-nearest neighbors, and a simple neural network. And we use the k-anonymity values of 3, 10, and 27, as the earlier work presented last year showed that those lead to the lowest or maybe even an improvement in the accuracy. All right, so then for the results, first we measured how much energy does it cost to either anonymize or create the synthetic data. This is what you see here. And what we see to the left is that for k-anonymity, and to the right for the synthetic data. And what you probably first notice is that on the right we see that synthetic data uses up to 4 times more energy than the anonymizing of the data. Sorry, it's a horrible word. Okay, so then first, maybe to make it a bit more interactive, if you think that 4 times higher energy consumption for generating synthetic data is acceptable because of the enhanced privacy, then maybe you could stand up to see what your thoughts are on this. And either no one agrees or no one knows how to stand up, but if you don't agree, then you stay seated, of course. Sorry. I'm sorry? Well, this would be maybe between using k-anonymity or synthetic data. Okay, that was not much of a success. Well, proceeding to the next results. The energy cost of training on k-anonymized data. Well, the 2 findings here are that the energy consumption and the training time decrease as the number that we use for the k-anonymity increase. So that's interesting. And also on the left bottom, you see every time the student performance set that we use, it was a very small data set. So those are really clustered on the bottom. Then for the synthetic data, what we saw is that there's very little variance in the measurements. They are really tightly put together. And that training on synthetic data uses more energy compared to k-anonymity, which makes sense because synthetic data, of course, mimics our original data set. Okay, then the accuracy impact. I didn't want to bother you with tables, so I used these horrible colors to show you. Then our findings are that synthetic data outperforms the benchmark, so no anonymization method for the student performance set. And for the adult data set, which is a bit bigger, we see that it underperforms on the benchmark, but it's just 2%, and that's compliant with related work. Then for generalization and suppression, we see that the k-nearest neighbors algorithm performs better on k-anonymized data than on the benchmark, which is probably due to some clustering effect, but there's still being research conducted on that. And that logistic regression and a neural net have a very similar performance, and well, it seems rather stable regardless of the chosen k-value. Okay, so take me home for synthetic data is that synthetic data consumes up to 4 times more energy to generate than to anonymize your data, and that the models trained on synthetic data perform slightly less or slightly better, but rather similar to the original data, which is good because that's what it should do. And then, would you say that the benefits of enhanced privacy outweigh a 2% loss in accuracy? So synthetic data enhances the privacy a bit better than the k-anonymity, but yeah, the accuracy could be reduced by 2%. Would you deem this acceptable? So please, yes, if you stand up, and no, stay seated. All right. I think that's about 50-50. It would be interesting for the discussion later on. Let me proceed. So in general, the conclusions, the energy cost of privacy enhanced data is lower for k-anonymity than synthetic data. And yeah, the energy impact of the accuracy impact of models trained on k-anonymized data is a bit inconclusive. It changes a bit, probably due to the data set. And the models trained on synthetic data have a similar accuracy and energy consumption than the original data, which is what it should do. And in general, techniques such as k-anonymity and synthetic data could enhance privacy. But the most important finding of our study was that it can also actually improve the energy consumption without any accuracy cost. So while they might seem two orthogonal directions, energy consumption and privacy, they actually could go hand in hand. All right, and then this would maybe be for the discussion. Thank you.